This video consists of 3 parts, and you can skip to the ones that interest you the most. First are my musings on AI's creative capabilities. Then there is a short summary of the limitations of current video models and how to work around them using different agent architectures and workflows. And finally, the most exciting part of this video is the like no other video agent walkthrough. I will demonstrate how it works using a commercial that most of us either don't remember or have never heard of. Yet, it's been labeled one of the most iconic and influential ads in advertising history. There is a lot of debate around the capabilities of generative AI. While it's straightforward to say that it enables us to do things that were once either impossible or required specialized skills and significant time, the discussion around its creativity, output quality, and trustworthiness is still ongoing. This experiment, using a video agent powered by Google ADK framework and Gemini 2.5 Pro in think mode, was my way of exploring how far an agent with minimal instructions could go in terms of creativity. It orchestrates some of the best image, video, and audio models available today to investigate and reimagine some of the most iconic commercials made by humans. While working on it, one thing became very clear, even though video generation is now accessible to everyone, creating a compelling video, one that lasts beyond the fleeting popularity of a YouTube short, still requires a lot of thinking and specialized skills. Right now, video generation also requires a good understanding of how each model works and how to prompt it effectively. Different models behave in widely different ways, which makes it hard to build a generic video agent that produces reliable results. It's even harder to rely on a model alone to generate a good video prompt in a single iteration. Without manually fine-tuning the prompt, the quality will almost always suffer. Another major limitation is video duration. Most commercially available models are kept at around 10 seconds. That's because the cost of generating longer videos is not linear. Also, longer videos suffer from temporal inconsistency and error accumulation. And just like with language models, video generation models have a limited context window too. In short, the longer the prompt and the video output, the higher the cost and the lower the quality. That's simply the state of things in mid of 2025. Still, we do have options for creating longer videos. Thankfully, most videos are a collection of scenes, so there is no need to generate one long continuous shot. Let's take a look at the different approaches you can use. One option is to create a video composed of multiple scenes, each inspired by a user-provided theme or a user prompt. The user provides a single prompt to the LLM, which then generates 3 text-to-image prompts aligned with the theme, along with 3 matching image-to-video prompts. The text-to-image prompts are used to create 3 images. Here are the images, which are then passed along with the corresponding image-to-video prompts to a model to animate them. So each video prompt results in a short video. Optionally, at the end, an audio prompt can be generated from the scene descriptions and passed to an audio model to produce a soundtrack. At the end, all generated video clips are stitched together and the audio is layered on top to produce the final video. Alternatively, you can already have an image you'd like to animate. For example, a product you want to feature in a short video. You can start with both a prompt and an image. In this case, the agent first generates 3 image-to-image prompts. These are the 3 prompts, and each is paired with a matching image to video prompt. The image along with each image-to-image prompt is then passed to a model to create 3 new images. Those are the 3 new images showing the product in different settings. These are then animated using the corresponding image-to-video prompts. The final video is assembled from the resulting clips and the audio. This is an example of agent architecture that does exactly that. You can see there are the image and video prompt generator, image-to-image generator, image-to-video generator, the concatenate videos to and text-to-audio generator, and then there is the merge video and audio tool. And let's take a short look how such a video could look like. If you still want to create one continuous, longer video, one approach is to start with a single text-to-video prompt based on a specific theme, and then continue the animation by using one of the final video frames as the image input for the next scene. To do this, you need to create a sequence of prompts. The first is a text-to-video prompt, and the following are image-to-video prompts. Each image-to-video prompt uses a frame extracted from the previously generated video as its input. Another option is to start with an image and a theme and generate several image-to-video prompts. In this case, the provided image serves as the input for the first scene, while the following scenes begin with animated frames taken from the end of the previous video segment. The main challenge with this workflow is that the extracted frame may not be ideal for animation. It might be blurry due to motion or poorly composed to serve as a starting point. To avoid wasting resources and money, the agent should ask for approval before proceeding with animating the extracted frame. Here's an example of an agent architecture for generating a progressive cinematic sequence from a user-provided theme. Let's take a look. There is the video prompt generator, text-to-video generator, extract last frame from video to image-to-video generator, then concatenate videos, text-to-audio generator, and again merge video, the final tool, merging video and audio. And as you can see, here is a communication back and forth between the agent and the human, because the human has to approve the frame which has been extracted in order for it to be animated. Let's take a look at the video which is generated this way. And And finally, I've reached the point where I get to talk about my favorite video agent. I named it like no other, inspired by the Sony commercial Color Like No Other. The idea was to truly explore what happens when you create an agent that doesn't follow a strict execution flow, but is instead left to its own devices and the model's imagination. The agent uses some of the best image, video, and audio models available today and the Google ADK Think function to plan its creative process and then execute it. It's instructed to begin by calling an OpenAI agent wrapped as an ADK tool to research and structure information about your favorite ad, including the ad in nutshell, the scenes, why it resonated, and the music. Once that's done, the agent decides which models to use and in what sequence to bring the ad to life. It can go straight to text to video or choose to first generate an image and then animate it. It gets to pick between different models. But guess which image and video tools a Google ADK agent powered by Gemini would naturally prefer? So, to shake things up, feel free to comment out the 𝗿𝗏 tool. You can also adjust the instructions to guide the agent when to give a preference to a specific model or tool. Video length is capped at 30 seconds, but you can generate longer ones if you're willing to pay the price for a good laugh. Just change the duration in the agent's instructions. And here is the implementation of the agent. It's not advisable to generate longer videos. Let's quickly take a look at the tools again. So this is how the agent definition with Google ADK works. It's the standard pattern where we pass the agent a name, a model, and a short description. Then the most important part are the agent instructions, and down here are the tools with which it has been equipped. And this is the so-called think function or planner function, which enables the agent to think through the task which it has been given. And the rest here are just the two definitions, maybe just quickly going from top to bottom, importing all the libraries which would be used, all the dependencies, then initializing the keys, and the starting tool is the OpenAI agent, which is wrapped as an ADK tool. The OpenAI agent is tasked with investigating the ad and the background of the ad, creating a short summary, which is then written in a markdown file. Let's quickly take a look. It just uses the internal web search tool. I wanted to use OpenAI web search tool because I like it better, and the result from the investigation of this agent, of the campaign, of the ad, is written in this markdown file. Then here comes the first tool, ADK tool, which is simply wrapping the OpenAI agent as a tool for the Google ADK agent. And the Google ADK agent is also equipped with a tool which reads the produced from the OpenAI agent markdown. So it just opens the file which contains the description of the ad, and it reads through it and uses its think function to plan the ad. And once this is done, it decides which tools to use in order to recreate, to reimagine the ad. We have the text to image with Imagen 4, and so on and so on. All the tools which have been used are listed in the tools here. passed to the agent. I've been using 𝗵 as a service for all the different video and audio and image generation models, because it's very easy to work with, and it provides a one point of access to all of those tools. And also it does not offer plans, but the billing is on pay-as-you-go basis, which is what I wanted to have. And now let's take a look at how the agent works. By the way, you can find this notebook in the GitHub repo shared below this video. So I asked the agent to recreate the 1984 Apple commercial, and here's the final outcome. Unfortunately, Google Colab truncated the execution output because it was too large. If you'd like to see the full output, you will need to either run the notebook in 𝗵𝗶𝗀𝗃 or execute the agent using the code in the last cell, which will return only the two outputs. The agent starts by planning its steps and then proceeds to execute them one by one. Its thinking is quite amusing if you have the patience to read through it. Here it is. My initial assessment is this. The task is clearly defined, and my understanding of the 1984 Apple commercial is strong enough to tackle this, and it goes so on, so on. First, I will need to meticulously deconstruct the original art using the Ask OpenAI agent. Let's in fact take a look at what the OpenAI agent produced. It says, the art in a nutshell, the Apple's 1984 commercial directed by Ridley Scott aired nationally during Super Bowl on January 22, 1984, and so on and so on. It has extracted the scenes, the opening, the Big Brother's address, and so on, and it also has elaborated why this art has resonated and what was the music theme used in it. Then it proceeds forward and creates, let's take a look, the first image, which is then sent to a video model to be animated. We can take a look at this one in the notebook because it is still available here. And then it creates the second image, and this is where the final, where it ends, because the data is too large to be displayed in the execution output here. Overall, this was a fun experiment that quickly demonstrated why some jobs are best left to trained professionals, and how limited an agent's creativity still is, unless you build a highly tailored video workflow with a human in the loop at every step to review the output. And frankly, that process will be slower than just using some of the video generation tools yourself and stitching the video manually. Finally, let's watch the video, and thanks for watching.